Hi guys, welcome to the notes for 4-2. This lesson is titled, Do You Ever Feel Like You Are Going in Circles? This will be our reintroduction of the unit circle today as we take the radian measures that we started reviewing yesterday and apply them to the unit circle so we can start using it. This first question asks, what are the radian measures that correspond to the following degree measures? You'll see on there we have 30 degrees, 45, and 60 degrees. Remember, these are the special angles that we used when we were memorizing the unit circle and using it last year. These are the ones that are marked on the unit circle. So if you wanted to, you could take this and you could do your conversions, right? You could say 30 degrees times pi over 180 gave you 30 over 180 pi, which gives you pi over 6, right? So we know 30 degrees is pi over 6. And you could do the same thing with 45 degrees and 60 degrees. When you do, you're going to find that 45 degrees was pi over 4, and 60 degrees, our bigger of the three angles, would then be pi over 3. These are very important. We want to make sure that we rebuild that relationship that we have where 30 degrees and pi over 6 go together. Our 45 degrees and pi over 4 will always be linked, and then the same thing with 60 degrees and pi over 3. All right, let's move on. So we're going to review these in our unit circle. So we're going to kind of reconstruct some of the unit circle in terms of the radian angle measures right here. First thing we'll start with are the axes. Right, so in our standard position here, when we go on our x-axis over here, we know that this is going to be 0 radians. And as we extend halfway around the circle and get to the other side here, we know that this is going to be pi radians. And then when you come back to the other side here, this also ends up being 2 pi radians. If we take that top half of the circle, though, and we cut it in half and we look at our y-axis, right, our y-axis here would end up giving us halfway to pi, so that'd be pi over 2. And then as we started at 0 and we went 3/4 of the way around the circle, we'd end up at 1.5 pi, or what we usually write instead is 3 pi over 2. And then these other lines that you see on the unit circle all go with those special angles that we were just talking about in the previous slide. So we've got our 30-degree angle, remember we said was going to be the same as like our pi over 6 angles. We've got our 45-degree angle is going to be the same as our pi over 4 angles, and then our 60-degree angles is going to be the same as our pi over 3. All right, so let's get started. The one I usually start with is the pi over 4, actually, because I like to just take each of these quadrants here and I just break them in half. So I know that halfway is going to be my pi over 4. So I'll actually just draw the whole full diagonal right through the circle. And then I'll do the same thing coming diagonally the other way as well. So we've got that on there. So if I start at 0, right, this is like 0/4, but then I go up to that first red angle, I know that's 1/4 of the top half of the circle. So this is pi over 4. When we get to the top, that's like 2 pi over 4 or pi over 2. That makes this 3 pi over 4. And then when we get halfway around the circle, that's 4/4 or pi. We go to the bottom, we'll add another fourth, that's 5 pi fourths. The very bottom, 6 pi fourths is 3 pi over 2, and then we have 7 pi fourths on the right side, and then we get all the way around the circle, and we're at 8 pi over 4, which is 2 pi. And usually I like to do my 60-degree angles, which is like my pi over 3 next, so I'm going to draw in those diagonals, right? These diagonals are representing like the corresponding parts here, so we've got 4 angles that correspond with each of these. These are the ones that are the farthest away from our x-axis. So if I started at 0 and I went up to my first pink angle, I know I've gone 1/3 of the top half of the circle. So we call that pi over 3. Then we go all the way over here. So now we're at 2/3 of the way, so 2 pi over 3, and then we go all the way down to pi, which is like 3/3. Then we extend 1/3 of the way around, we're at now 4 pi over 3. Then we're over to the next one here, which is going to be 5 pi over 3. And then we're at the very end again, which is like 6 pi over 3, or 2 pi. And then the last one we have there is our 30-degree angles normally, which we refer to as pi over 6 here. And these are the ones that are the smaller of the three special angles, and they're the ones that are closest to the x-axis. So let's just go ahead and draw those in so you can see the blue ones all correspond together, right? These are creating those bow tie angles that we like to call them. So this is going to be our pi over 6. So we've broken the top into 6 parts. So right here we're at pi over 6. If we move up here to like where pi over 3 is, that'd be 2 pi over 6, which reduces to pi over 3 obviously. 3 pi over 6 at the top. This would be like 4 pi over 6. Now we're over here at 5 pi over 6. Halfway would be 6 pi over 6, which is just 1 whole pi. Then we add a 6th, we'd be at 7 pi over 6. 8 pi over 6. At the bottom, 9 pi over 6. 5 pi over 3 is the same thing as 10 pi over 6. And then we get to the last blue angle here, which would be 11 pi over 6. Before we get to the end, 12/6, which is 2 pi. So those are the radian measures and the special angles that we tend to use the most with our unit circle. Okay, now some special things to remember. Take a look at your denominators as you move away from the x-axis. You know, all of our 6ths are the closest angles to it. Then, as we go a little bit farther away, our denominator decreases, we're at our 4ths. And then we get even further away from the x-axis, we're at our 3rds, which are the farthest angles away. There are so many patterns that you can use to help you remember where all these angles are. Okay, we'll talk about more of them in class. I know we've talked about them in Algebra 2, so I don't want to do too much with it here. But hopefully you've got some of this memorized, or you can recreate it if you need it. Now let's recall our special right triangles. Okay, in geometry, you learned about 45, 45, 90 right triangles and 30, 60, 90 right triangles. And we knew that with our 45, 45, 90 right triangles, we had each leg is the same because it's isosceles. And our hypotenuse is radical 2 times longer than either of the legs. For the 30, 60, 90 right triangle, we know that the 30-degree angle is the smallest one, which means the shortest side is across from it. We'll call that x. You know that the hypotenuse is always twice as long as the shortest side. And then the side opposite the 60-degree angle is the one that kind of falls in the middle. It's going to be radical 3 times longer than our short side. And we can use this to help us come up with our coordinates on our unit circle by thinking about those special right triangles. Okay, remember our unit circle has a radius of 1 unit, so we're thinking about these right triangles each having a radius or a hypotenuse of 1. So if we think about that, right, this one on the left side is like our 45, 45, 90 right triangle. Okay, and we know that it follows that pattern where this is x radical 2 if these side lengths are x. So we can use that to help us figure out what the value of x is going to be. Let's just take this and say if x radical 2 is supposed to equal 1, because that's what we have written over here, then we can solve it for x by just dividing each side by radical 2. And we have x is equal to 1 over radical 2, which we know if we rationalize our denominator should look a little bit more familiar as radical 2 over 2. So the side lengths of each side of this right triangle will be the square root of 2 over 2 for both. And then our 30, 60, 90 right triangle, right, we have, this is our 30-degree angle, this is our 60-degree angle. Okay, and we said that those rules from above are this one, if we called it x, our hypotenuse would be 2x, and the side opposite our 60-degree angle would be x radical 3. So again, since we know that 1 should be equal to 2 times x. We can use that to solve for x. We get x equals 1/2. So we know that this side right here is 1/2. But then we can take that value, that 1/2, and we're going to plug it in down here and multiply it times radical 3, and you'll see what we get for the length of that third side should be that third fraction that looks familiar to you, the square root of 3/2. So these fractions are extremely important when it comes to the unit circle, right? This helps us find those coordinates. And that's what we're going to do right now. Okay, so before we put those special angles in, let's put in all the ones that are on the axes first. We know on our positive x-axis, this would be the point 1, 0. We know on the left side on our x-axis, we're on the negative side, so that'd be negative 1, 0. At the top on our y-axis, it would be the point 0, 1. And at the bottom of our y-axis would be 0, negative 1. All right, so we need to just think about those 4 corresponding angles, right? If we can find those angles in our first quadrant, we can put the coordinates in for any of these. So just think about this. If we take our smallest angle first, right? Remember this one, it looks like our smallest angle. It's radical 3/2 for the horizontal part of it, and then 1/2 for the vertical part. If we just take that, right, since I can't move the triangles on the iPad, I'm just going to use this, right? Notice how that matches up with that bottom angle, right? So if our bottom angle was that pi/6, and if you want to write that in there, you can, right? You could say this is our pi/6 angle. We know that the x-coordinate is radical 3/2, and our y-coordinate is 1/2. Okay, well, that also, right, would be the same distance for our angle that's over on this side too, right? It's going to be the same distance across here and up. Okay, the only difference here is now we're on the negative side for our x's. So our angle here was 5 pi/6, and our coordinate should have been negative radical 3/2 positive 1/2. Okay, and then we could find the one that's down below, right, because it's going to be the same x-coordinate as we go down here. This is, our 7 pi/6. So we should have a negative radical 3/2 and a negative 1/2, because now we're below the x-axis. And then the last one there, right, in our fourth quadrant, if we just extend this down here, right, kind of notice our bow tie coming into play. We've got our angle being 11 pi/6. Okay, so we know that it's going to have the same x-coordinate as that angle above, so radical 3/2, and then we've got a negative 1/2 for our y-coordinate. Right, and this works with all of our special angles. So once we know this angle right here, right, and its coordinates, we can use that to find all of the other coordinates, right? Notice these are all pi/6 angles. Let's do the next one here where we had our radical 2/2. Our radical 2/2, this is like our pi/4 angle. Hopefully you remember that from in the past. So if we take this, right, and we move it over here, notice it matches up perfectly with that middle angle. We know that middle angle now is pi/4. So each of those side lengths would be radical 2/2, radical 2/2. That means our angle in the middle on the other side, right, if we took it here and we drew that one in, right, we have that triangle right here, we've got our angle being, what is that one? Do you remember? 3 pi/4. This one, we'd have a negative radical 2/2, comma, positive radical 2/2. Okay, and then I'm not going to draw all these in there. I'm going to go down to the one down below. We know that these ones are both going to be negative. This would be our 5 pi/4. Okay, and the reason I'm writing these in there is because, it makes it easier to memorize the more you write them down and talk about them. So this is negative radical 2/2, negative radical 2/2. Last one over here, which would be our 7 pi/4. We'd have radical 2 over 2, and then a negative radical 2 over 2. And then we have the last set here, which, our x and our y coordinates flip because our 30 and 60-degree angles flip. So that is going to be this one that extends up to here. Notice it's higher or farther from the x-axis than it is from the y-axis, right? So it means our x-coordinate is going to be a little bit shorter than our y-coordinate. So for this angle, which we call pi over 3, right, our x-coordinate's got to be 1/2. And then we'd have radical 3 over 2, which means over here, when we have our 2 pi over 3, right, we still have our 1/2 and radical 3 over 2, except our 1/2 is now negative. And then, right, so that's, think about it there, right, it's still above. Now when you go down below, down into the third quadrant, right, we're at now 4 pi over 3. Okay, we are going to have a negative 1/2, negative radical 3 over 2, and then our last one right here, which was 5 pi over 3. We've got a positive 1/2, comma, negative radical 3 over 2. So you just need to make sure that you remember this first quadrant, and you can use it to create each of the coordinates from the other quadrants. Okay, and you're going to be doing a lot more of this than you did last year, so you got to make sure you're ready to go, right? So all these ones that are colored here, right, are corresponding angles. They all have the same coordinates. We just have to figure out where the pluses and the minuses go. Let's move on. So here is a completed unit circle. Okay, so when we're talking about where the pluses and the minuses go, this is what you need to make sure you remember, right? In our first quadrant, we've got positive, positive. In our second quadrant, we've got a positive for our y, but our x becomes negative. When we get down to that third quadrant, remember they're both going to be negative. And then when we get to that fourth quadrant, we know that the x-coordinate is positive and the y-coordinate is negative. Okay, and if you just visualize, that helps a lot. So these say give the exact coordinates for the following angles. And right now, I mean, if you need to take it here and look at it there, right, if I said 2 pi over 3, I know that I could say, all right, well, 2 pi over 3 is this angle that opens up and goes up here. What's the coordinate? Well, these are the coordinates, negative 1/2 radical 3 over 2. Okay, but you need to think about, this triangle that's formed, right? Think about this triangle that's formed. Is the pi over 3 angles, right? Think about this y-coordinate, this side of it, right, is much longer than this side of it. Okay, so that's one way that you can help to remember which side's the 1/2 and which side's the radical 3 over 2. The y-coordinate's got to be higher, right, because it's a longer side of that right triangle. So with that one, since we know the pi over 3's are longer, we've got our coordinate, right, our x we know is going to be negative 1/2. We said radical 3 over 2 for the y. For 7 pi over 4, right, okay, for these ones we can also take them and draw them out, and I would get in the habit of doing that there, okay, so you're not always going to have a unit circle in front of you. Okay, so 7 pi over 4, when we think about it, those are our middle angles, right, the pi over 4s. We can take it and we can just draw it as well, right? If I start here at 0, this is 1/4, 2/4, 3/4, 4/4, right? 4/4 is 1 whole pi, 5, 6, 7. So it's this angle right here. So we are down in the fourth quadrant, right? Our fourth quadrant we know is going to be a positive, negative. And since pi over 4 we know is radical 2 over 2, radical 2 over 2, we'll just say this. This is going to be a positive radical 2 over 2. And then because of our y being negative, negative radical 2 over 2. For the next one, we have theta equals negative pi over 3. So negative pi over 3, remember that's a negative angle. Okay, and our pi over 3 angles are the ones that are farther from our x-axis. So that means we're going to go this way down here. So we're going to end up down in that fourth quadrant. This is the same thing as our 5 pi over 3, right? This coordinate that we end up with down here. But think about it there. It's way more vertical than it is horizontal. So when we think about its coordinates, the x-coordinate's got to be a positive, the y-coordinate's got to be negative. When we're taking it and writing it out, we know it's going to be a positive 1/2, comma, negative radical 3 over 2. Well, hey, look, doesn't that look a lot like what we have up above here? These are both pi over 3 angles. Okay, we just have to figure out where that plus and minus goes. So this last one here, we have theta is equal to 11 pi over 4. Okay, so 11 pi over 4, if you think about that one we don't really see on the unit circle, but we could take it and we could count it up, right? So let's count those. We've got 1, 2, 3, 4 fourths, 5, 6, 7, 8 fourths, right? 9, 10, 11. So we know that we're going to end up here in that second quadrant where we're negative, positive. And since we already know it's radical 2 over 2 and radical 2 over 2, when we write this out, we're going to know that our x-coordinate is negative. So negative radical 2 over 2, comma, radical 2 over 2. And that is our answer. Now let's think about how do we find some of these angles that are not special angles. Okay, so this is important, and this is where people tend to struggle a little bit. So hopefully you'll be paying attention as we do this. Okay, I'm going to give you a couple little helpful hints here, or things that you can do to make it easier on yourself. So it says determine in which quadrant each angle lies. So the first one we have is 5 pi over 8. And mathematically, we could figure out how many radians it is and then figure out where it is just by comparing it to the total number of radians in a circle. However, if we wanted to draw it out, sometimes that's the better way to do it. So what I'm going to do here is I'm going to draw my x-axis first. And anytime my denominator is even, I'm going to draw in my y-axis. Okay, so when it's even, I'm drawing in the y-axis. And here's why. If I want to break this into eighths, okay, if I'm breaking into 8 parts, I need 7 diagonals. Okay, so if I want to break it into 8 parts, I need 7 diagonals. Well, that's an odd number, and that's hard to draw an odd number in here. So we're going to use that y-axis as one of our diagonals. So now I only need to draw in 6 more. I can draw in 3 from that first quadrant. Oh, those aren't really that great, but bear with me. Okay, and then I'm going to draw in 3 in that second quadrant. And I'm going to just extend them through the origin so it kind of covers the entire unit circle. Yikes. Okay, not my best drawing, but bear with me. They don't have to be drawn to scale. Notice this is broken into eighths now, right? I can say this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, so I just want to make sure you understand that there. We broke it into eighths there. So to break it into eighths, you need 7 total diagonals. Okay, this would be 1, and then you've got 2, 3, 4, 5, 6, 7. Okay, now all we're trying to do is go 5 pi 8. So we're just going 1, 2, 3, 4, and then 5. So this angle that we have right here is our 5 pi 8ths. So we know that we are in quadrant number 2. Looking at the next one, we have negative 2 pi over 5. Okay, so when we've got an odd number in the denominator, we are not going to draw in our y-axis. Okay, so here's what I'm going to do. I'm going to put in just a dashed y-axis. We're not going to count that as a diagonal. Notice we counted it as a diagonal in the previous problem. We're not here. So I need, for five parts, right, I need 4 diagonals. So I'm going to take this here, right? This is still my origin there. I'm going to count in there. If I need 4 diagonals, I'm going to put 2 on the right side. So we've got 1, 2, and then I'm going to put 2 coming in from the left side. So I've got 1 and 2. Oh my gosh, that's really bad. But it's still broken into parts. They're just not drawn to scale. They're a little ugly, but sometimes things are ugly. So we're going to go 1, 2, 3, 4, 5. Do you see how it's broken into 5 parts? I did not count the y-axis on this one. Okay, so let's count now our negative 2 pi fifths. So we'd start here and we'd say just 1, 2. That one's actually pretty easy, right? So our angle is this angle right here. So we've got negative 2 pi fifths ends up being in the 4th quadrant. Still need to know how to draw them if you need to. That's why we're practicing this. Let's go down to C. We have 19 pi fourths. Okay, again, this one, even number in the exponent there. If we're trying to break it into 4 parts, there we go. If we're trying to break it into 4 parts, remember we need 3 diagonals, and that y-axis is going to count as a diagonal. So I'm going to say here, x-axis, y-axis. So there's 1 diagonal. I just need 3. So I'll put 1 on this side and 1 on that side. And now we can start counting out our 19 pi fourths. So 1, 2, 3, 4, 5, 6, 7, 8. Right? We know that that's going to be 2 pi. Right? We'll probably have to go another 3 pi. So we're at 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 2 pi and another 2 pi. So that's 4 pi. And then 17, 18, 19. So this one ends up being in quadrant 2 also. Hopefully you see how we did that. Okay, so now we're on to the last one. This one's negative 11 pi over 3. Okay, so again, now we're back to the odd number down here. So remember, if you've got 3 parts, we've got 2 diagonals when we're trying to draw it. So let's try this here. We've got our x-axis. We're going to just draw our y-axis in as a dashed line. It does not count as a diagonal. So I just need 2 diagonals. So I'm going to go ahead and put 1 here, and I'm going to put 1 right there. And now we're going to count them out here. So we're going negative, remember. So we're going to say 1/3, 2/3, 3/3, 4, 5, 6, 7, 8, 9, 10, 11. So this is where we end up at for this one. And that one's going to be in quadrant number 1. Okay, so the reason I really try to re-emphasize everything here is because I know in the past that this has been a struggle for people. So hopefully that will help you. Let's just do a little bit more and then we're finished. So non-special angles, we have 11 pi over 8. It says, in which quadrant does the angle exist? Well, it's exactly what we just did. If you want to practice drawing it, I know some of you could probably just look at this and tell me what it is there, but you may not be able to do that with all of them. So 11 pi over 8. Okay, we know that it's more than 1 pi, but less than 2 pi. So probably somewhere in quadrants 3 or 4. Okay, but if we're just practicing drawing these out, right? So I'm going to count my y-axis as 1, and I need 7 diagonals, right? So there's 1, so I need 3 on each side. I got 1, got 2, got 3, and then we've got 4, 5, and 6 there. So now it is broken into 8ths. So if we count it up here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the angle. If we were asked to draw it, that's where it's going to be. Okay, so what quadrant are we in? We're in quadrant 3. Okay, so this is our 11 pi over 8. Now it says, what is the reference angle? So we haven't really talked about those with radians yet. I know we did them with degrees, but remember, that's the angle that's formed between the x-axis and our terminal side. So it's this acute angle over here. So if this is 8/8 pi over here, or just a whole pi, we know that we're going to end up going down 1/8, 2/8, 3/8. So our reference angle would end up being 3 pi over 8. Okay, that's the measure of this angle. Whoops, I didn't mean to use red and write it out there, right? So this is our reference angle. Now it asks us to find the following: a positive coterminal angle. Okay, so now we're in radians. Remember yesterday we added 360 degrees or subtracted 360 degrees. So when we're talking about radians, we're just going to, instead of using degrees, we're going to change that to a 2 pi. So if I start at my 11 pi over 8 and I add 2 pi, right, I'm going to go all the way around the circle and I'll end up right back in the same spot. So that's pretty easy to do, right? 11 pi over 8. If I add 2 pi, right, we got to get the same denominator. So we know that's the same thing as 11 pi over 8 plus, what would that be, 16/8. And when we add those together, we should get 27 pi over 8. That is a positive coterminal angle. A negative coterminal angle, right, we're just going to take it and we're going to subtract, right? We're going to subtract. So from 11 pi eighths, when we go around this way, right, we should end up back at 0 right here. So then if we keep going all the way back around, we'd end up at some sort of negative angle. So we'll say 11 pi over 8 minus 2 pi, and again, that's the same thing as 16 pi eighths, so 11 pi over 8 minus 16 pi over 8 should give us a negative 5 pi over 8. So that is our negative coterminal angle. All right, hopefully this helps. If you have questions, please make sure you reach out, especially if you're on your remote week. It's not an excuse not to ask questions. So if you need assistance, you need to make it known and we will help you. Thanks for watching.